Okay, one last rational function to graph. These are fun. I like them. What are we going to do? Oh my goodness. Notice that the degree of the numerator is exactly one more than the degree of the denominator. What does that mean? That means we're going to have an oblique asymptote. What's that? It's a slant asymptote. And how do you find your slant asymptote? You do some division. So since we're dividing by x minus 1, we can absolutely use a synthetic division. Um, oh, and also, uh, there was a typo on your study guide. And I told you in class, hopefully you made it, that should be a minus 4. Okay, so synthetic division, our polynomial is 1 minus 3 minus 4, and x minus 1 is what we're dividing by, so we need a positive 1 right there. Okay, so synthetic division, bring it down. There, it's brought down. 1 times 1 is 1. Negative 3 plus 1 is negative 2. 1 times a negative 2 is a negative 2, and negative 4 minus 2 is a negative 6. Boom. That negative 6 is our remainder. You should get a remainder when you're doing a slant asymptote problem. If you don't, then maybe there is a problem. Or maybe there's a hole. Ooh, interesting. Kinda, maybe. I think it is. Alright, so, what do we know? Well, we know that 1 minus 2 is a polynomial. It says 1x minus 2. But what about that gosh darn remainder? What do we do with it? Well, x minus 2, that's kind of the key. That's the important piece. That is our slant asymptote. But what's kind of cool is that we can say that the original function h of x will equal that slant asymptote, x minus 2, the thing we got when we did our division, plus our remainder of negative 6 over our original divisor, x minus 1. What? That's nuts. That's weird. But again, what's the key here? The key is that the slant asymptote is at x minus 2. Why is that? Well, that's because this term, negative 6 over x minus 1, that thing in that little dashed box has a horizontal asymptote at 0, which means eventually it is essentially equal to 0 and thus does not affect the graph, and the graph just looks like x minus 2 because it gets so small. All right. I'm fidgeting. I'm making these videos in my bed because I'm tired. All right. What do we do? Where do we go? How do we graph this? I don't know. Wait, I do know. Okay, let's factor it. X squared minus 3x minus 4. Let's factor the numerator. How does that factor? Well, that's going to factor as x minus 4 times x plus 1. Because negative 4 times 1 is negative 4. And a negative 4 plus 1 is negative 3. So there's that. Denominator is x minus 1. So what do we know? We know we have x-intercepts at, what? 4, comma, 0. And at negative 1, comma, 0. And we know we have a vertical asymptote at x equals 1. And we know we have a slant asymptote, an oblique asymptote, at y equals x minus 2. It's a linear equation for our asymptote. Crazy. Alright. Do we know anything else? We can find our y-intercept. Plug in 0 for x, and what do you get? Well, you get negative 4 over negative 1. So you get a y-intercept at 0, comma, 4. Sweet. Let's graph it. So, axes, and plotsies. All right. 1, 2, 3, 4. I count. 1, 2, 3, 4. I still count. 1, 2, 3, 4. I don't know why I'm doing that, but it did. Whatever. put another one. All right. Y-intercept we said was at 4, so there's a y-intercept. X-intercept's at 4, 0, and -1, 0, right there. Vertical asymptote at x equals 1, so there's that. And a slant asymptote is the linear equation y equals x minus 2. Minus 2, that is our y-intercept of the slant asymptote, and the slope is 1, so that graph's going to look like that. Now, you can use the context of the problem to figure out where you are, right? Look to the right of the vertical asymptote. I have a 0, an x-intercept at the, I don't know what I'm saying, but an x-intercept to the right there, which means this thing has to go up like that. Like, once this stuff is all in place, you can't really graph it in more than one spot. Otherwise, it looks all like awkward and stuff. Like if I was up here, I'd have to be like, but that doesn't make sense because that's not a function. Or maybe I'd be like, and approach that asymptote. But that also doesn't make sense because you just create an x-intercept that doesn't exist. So like that's all super awkward, and that is just like a nice, pretty smooth curve. And then we can have another similar, nice, pretty smooth curve going right like so. And we're happy, and things look pretty gosh darn awesome.